All objects are made of atoms. Atoms, on the other hand, consist of nuclei, protons, neutrons, and electrons moving in an orbit around this structure. The flow or movement of electrons from one position to another is called electricity. There are two types of electricity: static electricity and dynamic electricity. The static electricity is produced when there is an excess or deficiency of electrons on the surface of a material. A discharge event or spark will occur when two oppositely charged surfaces are brought close to each other. Especially, when we wear woolen clothes, our hair gets electrified, and those little shock moments we experience when we touch other people around us are associated with this situation. The dynamic electricity is the flow of electrical charges through a conductor. In other words, electric current is called dynamic electricity. The electric current has two modes of transmission: direct current, DC, and alternating current, AC. The direct current, DC, occurs as electrons flow through a conductor from the beginning to the end. Alternating current, AC, is a type of electrical current, in which the direction of the flow of electrons switches back and forth at regular intervals or cycles. The electric potential difference that causes electric current to move between 2 points is called voltage. It is measured in volts and is denoted by the letter V. Electric current can be defined as the flow of electric charge or the amount of flow of electric charge. Electric current is measured in amperes, A, and is briefly denoted by the symbol, I. The resistance of a material to current during the passage of electric current is called electrical resistance. Electrical resistance is expressed in ohms, omega, and is briefly represented by the symbol, R. There is a correlation between the three basic concepts of electricity: voltage, V, current, I, and resistance, R. This relation is Ohm's law, which is the main formula of electricity. Resistors are electronic circuit elements that show difficulty in electric current. If the resistance value is high, the current passing through it will be low. The circuit element, which is obtained by placing an insulator called dielectricity between two conductive plates and can store electrical energy, is called a capacitor. It is denoted by the letter C and its unit is the farad, F. Semiconductors conduct current well under some conditions, not conduct under others. The conductivity of pure silicon or germanium can be adjusted by varying the number of free electrons or holes. This is achieved by adding an additive to the semiconductor. It is obtained when phosphorus atoms with 5 valence electrons, such as arsenic, bismuth or antimony, are added to the silicon crystal in a certain ratio. In N-type semiconductors, electrons are called majority carriers. Thus, in the N-type material, the current carriers are electrons. It is obtained when boron atoms, or aluminum, with 3 valence electrons are added to the silicon crystal in a certain ratio. Formation of p-type semiconductor material. In p-type semiconductors, the current is mostly provided by gaps. These gaps are called majority carriers. Systems that convert solar energy falling on its surface into electrical energy are called photovoltaic batteries, or solar cells. The solar cell consists of 2 basic layers. The layer where the sun's rays fall is called the window layer. And the layer where the rays are absorbed is called the absorption layer. The smallest unit of a solar system is solar cells. Cells come together to form modules. Modules come together to form panels. And panels come together to form solar fields. When the panels are connected in series, the short-circuit current remains constant and the open-circuit voltage gradually increases. When the panels are connected in parallel, the open-circuit voltage remains constant and the short-circuit current increases. The most efficient solar panel among the solar energy panel types is monocrystalline. This type of solar panel produces big energy in a small space. However, the price of monocrystalline energy panels is comparable to other solar panels is more expensive. We can say that the polycrystalline solar panel is a complete market product. It is balanced in terms of both efficiency and unit cost. And it is the cheapest solar panel. Many solar power plants are built with polycrystalline solar panels. Inverter, power converter or inverter, which can be defined as an electrical power conversion element, is used in many different areas from small power supplies used in computers to large systems powering electrical distribution systems. Inverter provides AC current at desired voltage, power or frequency values. The purpose of the inverter development is to save money. The inverter device, which cleans the voltage fluctuations and peaks coming. In addition to producing energy, one of the other important issues is to use energy with high quality. The first condition of using energy with quality is to follow it in every aspect. With network analyzers, it can measure every parameter of electricity, which is an invisible power, and savings in facilities. Various parameters of an electrical distribution system are monitored and measured with an energy analyzer. Solar batteries are generally used for storage. It has a feature that saves electrical energy to avoid working in current times. At the same time, the existence of sunless days is important for the storage of energy. The most important issue to determine the power of the solar battery is to calculate the number of days or hours that will not be sunny. For the installation of the system, first of all, the panels must be connected in series or parallel with each other. Since it will be charged, we can feed DC loads with cables coming from or going to the battery. The cables going to the inverter will go as DC and these will come out of the inverter as 220 AC and will feed the AC loads.